what is this novelty search algorithm and how does it work differently to be able to, I guess it sounds like it explores differently than other kinds of
Mhm.
machine learning algorithms, and that allows it to achieve great outcomes that would be possible if we were strictly following an objective function that could say, lead us to the top of a mountain when we were trying to get into outer space.
Mhm. Yeah, that's right. Like this all started with algorithmic insights, and you also have to keep in mind like this is stuff that happened, around a decade ago, and so you have to sort of put in the context of where the field was back then, and because some of these ideas have kind of like percolated into the field since then, so they may not be as novel now as they were 10 years ago, but I think they're still provocative, so you still probably find it interesting. So basically, I just want to put into like what was going on at that time. I believed in objective functions. I mean, I wouldn't have said it like that because I wouldn't even been thinking about this question. I mean, I basically
Right.
thought objective functions are like
There's
the
nothing to
way that
believe
you,
in. It
right.
just
Yeah. It's
is the
just sort of
way.
like obvious. Yeah. That's just what we do. And so I wasn't particularly trying to question them or anything like that. But we did this experiment it was a very strange topic. It was with picture breeding online. It was called Pick Breeder. And we like created this website called Pick
What is
Breeder.
that?
Okay. Okay. Yeah. So what is Pick Breeder? Is probably like you need to give a little background on what that even is. Pick Breeder was a website where you could breed pictures. Okay. So what does that actually mean?
Yeah, that's
Um,
that's what
like
I'm trying to
basically,
get to understand
yeah.
here.
So basically, what it was it had an archive of images that people had bred, and you could pick one of those images and breed it further. And what that would mean would be
Well, how do
like
you
you would.
breed an image? What does that
Right,
mean?
right. So what it means is basically, just from the surface level, basically what it would mean is that I could say I want this image to have children, and the site, which is basically like an online service, would generate children for that image. And
Okay,
basically, they're just mutations, like the way if you have children, they look kind of like you, but not exactly. Like the image would
right.
also have children that look kind of like it, but not
I
exactly.
see. And
And
so,
this
is there asexual breeding where an image just like multiplies into children, or is it always do they always have to be like two images that can breed together
you
and
could
create
do either
progeny?
one.
Okay,
Sorry, you could do either one,
yeah,
but mostly I think people are doing asexual. Asexual is just simpler and easier. It
right.
isn't really that important towards what happened, but yeah, asexual. I know it's asexual is very exotic and weird from our perspective, but within this kind of system, it's like it doesn't really matter. You can do lots of exploration with asexual,
Right.
and so yeah, usually single parents would have children. And then you can just keep iterating. You're basically just breeding. It's like breeding horses, breeding dogs, or something. Except it's very fast, of course, because you basically instant gratification.
It is, yes.
And
And
so,
there's less to clean up.
yeah. Well, that's true. Yeah, yeah. There's a very, very it's very much clear that they do biology experiments.
Yeah.
And so why did we? So basically, like what happened? Like, one other interesting thing is where it all began was like from a bunch of random blobs. And so, like, if you just said start from scratch, like, where does all of evolution begin or something, you'd get a bunch of random blobs. They don't look like anything. And what happened, though, is that through all this breeding, and recall that, like, part of what can happen is that I can branch from something that you had bred. So you would like publish your discovery to the site, and I could go and look at that and say, actually, I want to breed that further. So we got
Hmm.
people branching upon people, which creates what biologists would call like a phylogeny. It's like this tree of life basically was growing inside the system. So,
Hmm.
why did we do this? This actually, there's a meta story here which points back to why greatness cannot be planned, because it was actually like one of those things that's from an AI perspective is a little hard to justify. It's like, what is the objective of all of that? Like, why are we creating a picture breeding service and putting it? And I was like, basically, my theory was, I'm not exactly sure what's going to happen, but it's going to be really, really interesting. Like, that's pretty much what was motivating me at the time. Because I had seen these, like, sometimes they're called genetic art or evolutionary art or things like that. But like to actually put it on an online service where it just goes forever, like we could just keep branching off each other's discoveries, and with a very interesting representation under the hood. That's the other thing. So how does that work? Like, under the hood, there's a special kind of neural network called a compositional pattern producing network, which is generating these images. And it's basically designed to generate patterns with regularities and symmetries. And so it was like made for like exploring kind of like geometric patterns. And so, like, I thought like put all this together, like put people crowdsource the internet, like it's going to be just super interesting. And in fact, it was profoundly interesting because from that experiment, like thousands of images were bred, and what happened, like the first interesting thing that happened was that actually, remember, it starts with like totally meaningless blobs. People were breeding things that looked incredibly like stuff that we know from the real world, like butterflies and skulls and cars. And at first you may say, well, they're breeding, like it's not such a surprise. But actually, it's a huge surprise because it turns out that it's an extremely deceptive space. And these are very, very rare needles in a haystack. Like the whole space, like if you think of the whole space of CPP, of this compositional pattern producing network space, it's like 99.9999999% is just like complete garbage. So
Huh.
over and over and over again, extremely infinitesimal like needles in a haystack were being found consistently by our users. And they're like amazing likenesses of things. And you might think, well, but breeding could get you that, but it's actually not true. Like it turns out that like if I told you like breed a horse, it just you'll never be able to do it. And this is starting to get to this point of the problem with objectives. You can see how it starts to fall out here because I noticed that like people can't get to things when they want to, and yet they're finding all these things. And so the question, which I thought was like really
Right.
profound, which was the answer was discovered inside of PickBreeder, was how then are they finding things if you can't find things by looking for them? Like, so if you set an objective, like it's like, I want to get a butterfly, forget it. It'll never happen. It's impossible if you're starting from scratch. But people did discover a butterfly and over again, all kinds of interesting things. And it turned out that the answer was that people were finding things by not looking for them. And now this is totally counterintuitive. And like, it goes against everything that I had believed, because I basically believed in objective functions. Like I would have thought like, okay, the way to get butterflies is to try to get a butterfly. And the closer the image gets to a butterfly, the better I'm doing. I mean, that's maximizing the objective function, but it actually doesn't work that way. The reason that it works is because people weren't trying to get butterflies, which means that the things that lead to butterflies, which I call the stepping stones, like those things were being discovered because people weren't looking for butterflies. Because if they were looking for butterflies, they wouldn't have chosen those stepping stones. See, it's very counterintuitive, like because they don't look like butterflies. See, the things that lead to butterflies don't look like butterflies. Just like the things that lead to inventing computers, like which are vacuum tubes, don't look like computers to us. We wouldn't think that those would lead to computers. And this is true of just about every interesting invention ever invented by humankind. And it happens in PickBreeder. But the original revelation, like observing this in PickBreeder, to me, yeah, it was like an epiphany. I mean, it blew my mind completely because it was like I just was like, this goes against everything I've ever been taught, like especially in the field of machine learning. It's like we do things by setting them as objectives and then maximizing, or you could say like minimizing the loss, or however you want to put it. Like that's how we do things. Like in evolutionary computation, it would be like maximizing the fitness function.
Mhm.
And this is like that doesn't work at all. The only way to do these things is by not trying to do them, because the stepping stones will be lost if you do try to do them, because they're deceptive. Deceptive in the sense that the things that lead to the things you want don't look like the things you want. So if you're maximizing that I want them to look like what I want, then I won't get them. It's very paradoxical. And I spent weeks just like I was just like my mind was consumed with this insight like for weeks because it was just so bizarre and counterintuitive. And I started thinking, well, what would an algorithm that respects this actually look like? Because it's totally nuts. Um, and what I was thinking was like, imagine a car going around a track. And like normally, like, I mean, I've done this experiment like before where I just basically try to maximize the distance that the car goes before it crashes. And eventually, like, according to like the way we think about objective functions, eventually the car will go all the way around the track. And it's probably true. I mean, because driving a car around a track isn't super hard, like in some simulator or something like that. But I
Right.
thought,
This
what if
isn't
we
something
thought,
you're not every
yeah,
weekend demolishing a series of cars on a track.
yeah. So I thought, yeah, it has to be in a simulator. But I thought, okay, let's think about it in the pick breeder way. Like, and this is pre novelty search. I'll just think, what would that be like? So I thought, okay, instead of I'm trying to get around the track, which is the normal objective function, what if I just think about it? I'm just going to try to do something new that's interesting. So I don't even think about what's bad or good. Like, there's no concept like that. What would happen? Well, so the car would basically crash into the side of the track immediately. I mean, it doesn't know what it's doing. But then I would say, okay, let's have a rule. You have to do something different now. Because that's sort of like, sort of in my head, I was like, that's kind of what pick breeder users are saying. They want to find something new that's interesting. So now let's say, let the car try to follow that heuristic. So the car now can't crash the same way. It has to try to crash a different way, or not crash, but do something different. Well, likely it would just crash again, but it would crash in a different way. So it's going to crash over here. It's going to crash over there. It's going to crash all these different ways you can crash. But guess what? There's going to be this amazing moment, like this threshold that we cross where it won't crash, right? Because it's going to run out of ways to crash. Like someday it's going to happen that it's tried all the boring, easy things to do, and it'll be forced then to like actually understand what a track is, or like to actually look at its visual system and respect it in some way. And this is like a special, like a profound, change that will happen, but it's inevitable. It seemed to me it has to eventually happen. And then I was thinking, is that better or worse than like the usual way of thinking about this? The usual way of thinking is just maximize. Like every time you go, you try to go a little bit farther. But here I'm thinking, just do something new. And I start thinking like this is actually better because like if you think about it, like I don't actually know what leads me to going farther down the track. Like from like a neural network weights perspective, it's not clear that like just because I went a little bit that's actually close to going a lot. And it's not even clear that's even going in the right direction in weight space, which is this like abstract space of like multidimensional settings of weights in a neural network. So if you think about that, like this, you think about that the actual stepping stones that lead to getting around the track could be deceptive and counterintuitive. Then this is actually a principled thing to do. Is like just try something new. We don't even have a concept of getting around the track as something we're trying to maximize, or we don't even know we're trying to do that. Just try something new. If you keep trying something new, you'll run out of stupid things to do. Eventually, you'll do something that's not stupid. And eventually, you'll do something that's actually interesting and so forth. And so that started going through my head like, oh, this is an interesting way of thinking about progress in the world. It's quite different than maximizing or going down an objective gradient. And then that led naturally to this novelty search idea. So I thought, along with who eventually became my co-author on the book, Joel Lehman, who was a PhD student at the time, one of my PhD students, we thought together that, hey, we could write this as an algorithm. It's basically just searching for novelty, and it's really interesting algorithm. It's because it's kind of counterintuitive and paradoxical and crazy in a way. Is that the algorithm doesn't know what it's trying to accomplish. All it's trying to do is do something different than it's done before, and so it's completely anti-objective. But here's the hypothesis is that if we run this, it will end up doing things that are actually interesting and useful. And especially in constrained domains like a car on a track or like, say, a biped robot trying to learn to walk, I believed that it would actually learn to walk. I should add, it's very important to understand that in a very unconstrained domain, this isn't going to give you a single objective that you want. This relates back to the point that I made earlier, just in life, that like if you go with the interestingness heuristic in your life, you can't think about it as I'm going to solve problem X. What you think about it is I'm going to do something interesting. I might solve some problem, but I don't know which one. This is true of the novelty search algorithm as well. So like it's not like a solution that you don't want to think of it as a magic bullet, like, oh, well, this is going to now solve all our problems, because we don't know which problem it's going to solve. But in a very constrained domain, it actually does have the property that sometimes it just solves the problem because there's not much to do. Like for the biped robot, it's like it falls down in a new way, but eventually it doesn't fall down because like that's the only way to be novel. And eventually it will go some distance, and that's basically it's learned how to walk. So in kind of constrained domains like that, this actually can give you a solution. But in the bigger picture, the novelty search algorithm is really about finding interesting things that are out there in the search space and kind of plundering interestingness. But at the time, like we showed it in experiments that were in these narrow domains to make this very counterintuitive point that, look, by not having an objective, you get better solutions. And that was the fun part of it. Like if we tried to optimize the objective function, like tell the biped robot walk as far as you can, it would actually get you worse walking gaits than if we did the novelty search, which doesn't know what it's trying to do. And the lesson, I think, is not that novelty search is the solution to all your problems. Rather, I think what I take from it is that objectives are an absolute embarrassment. Like they should not be losing to an algorithm that doesn't know anything about what it's trying to do.
Right.
That just should be like ringing alarm bells all across the field about what we think, what we believe and have faith in as sort of intuitively the practical common sense approach to achieving something that's hard. And that was sort of how I tried to couch it, like in the early papers, is like, this is very concerning for our way of thinking, but also could be useful. It's liberating and concerning, because if you think about it, if you don't have to always be adherent to an objective, your life is a lot. I mean, I shouldn't say your life because we're talking about algorithms here, but like we're a lot less constrained in the way that we can think about achieving things. So a lot of creativity becomes possible. but that was the early kind of like genesis of the novelty search algorithm, and why it was kind of controversial, you can imagine, because it sort of like annoying to people who really do like this kind of objective maximization framework. But it was also liberating, and opened up a lot of new ideas and led to like entirely new fields. Like quality diversity is now a new field that like drew on those ideas.